Hey class, all right, we are back with part 2 of our fractions lesson. So let's talk again about what a fraction is. If I have a whole and I divide it into parts that are equal, I can talk about those parts as fractions. Remember that in order to have fractions, we have to have equal parts. So these shapes are divided into equal parts. These shapes are not divided into equal parts. These are unequal. I cannot make fractions out of unequal parts. They have to be equal parts. Okay, we can name our fractions based on how many parts there are. This apple has been divided into 4 equal parts. When I name those parts, I call them fourths. This sandwich has been divided into 2 equal parts. When I name those parts, do you remember what they're called? Halves. This pizza has been divided into 8 equal parts. When I name those parts, they're called eighths. Our pie has been divided into 6 equal parts. When I name those parts, they're called sixths. All right, we learned about numerators and denominators, but what you need to remember is the number on top is whatever I asked you about. So if I asked you how many parts are shaded, that's the number you'll put on top. How many parts in all is always what goes on the bottom. So how many parts were there in all, including whatever I asked you about. So that's how we got 1/3 for this shape. One part is shaded. So if I wanted to know what fraction of the shape is shaded, one part is shaded. So I put a 1 in the numerator spot. 3 parts in all. And how do I say this fraction? 1/3, right? Don't say 1/3. So 1/3 of the rectangle is shaded. Let's talk about reading this one. So I have one part that's shaded, 2 parts in all. When I read this one, I call it 1/2. 3 parts are shaded. There's one part one part that's shaded, 3 parts in all. When I read this fraction, I say 1/3. And then we have 4 parts in all. So there's our number on the bottom. One part is shaded. So one part is shaded, 4 parts in all. When I read this, I say 1/4. Okay, 1/4 of this circle is shaded, right? I have one part that's shaded, so there's my numerator, 2 parts in all. So put a 2 on the bottom, and when we read this, we say 1/2, not 1/2, 1/2. Let's shade a little bit of this triangle. So we're going to shade one part today. So if my question was, what is the fraction of the shaded part? One part is shaded. How many parts are there in all? That's your number on bottom. And when we read this, we say 1/3. We're going to shade in 2 of these, right? So if I said, what's the fraction of the shaded part? 2 parts are shaded. How many parts are there in all? 6. So how would you say this? 2/6 is shaded, right? Here's your triangle. One part is shaded, so there's your number on top. How many parts in all? And can you say that fraction? 1/4. Good. How many parts are shaded? How many parts in all? And how you say that fraction? 1/2. All right. Can't shade these very well because they're so big, but we're going to shade this one. All right, so our circle, how many parts are shaded? How many parts in all? And who can say that? 1/2. Good. Let's look at this circle. All right, how many parts are shaded? That's your number on top. How many parts in all? 1, 2, 3, 4 parts in all. So our fraction is 2/4. How do you say it? 2/2 is how you say that. That looks familiar. Does that look familiar to you? Does it look like the same size? It's because it is, right? So 2/4 is actually the same as 1/2. There's another equivalent fraction for you. All right, let's shade in this part. How many parts are shaded? How many parts in all? 1, 2, 3. And who can say that fraction? 1/3. All right, let's shade in that much. How many parts are shaded? 1, 2, 3. That's your numerator. How many parts in all? 1, 2, 3, 4, 5, 6, 7, 8. And how do you think we say that? 3/8. 3/8. All right, we're going to shade this part. How many parts are shaded? Count your parts in all. 1, 2, 3, 4, 5, 6, 7. Can you say that fraction? 1/7. All right. Here we go. What's our fraction of the shaded part? How many parts are shaded? 1, 2, 3. How many parts in all? 1, 2, 3, 4. What's the fraction of the unshaded part? This time we're going to say, okay, there's one part that's not shaded. And how many parts in all? Still going to have the same denominator. So 1/4 is not shaded. So 3/4 is shaded, 1/4 is not shaded of this square. All right, your number on top, how many parts did we shade? 2. How many parts in all? 1, 2, 3, 4, 5, 6, 7. And how are you going to say that fraction? 2/7. 2/7. Okay, little quiz. Which shape is divided into equal parts? I'm going to give you a minute to figure it out. All right, if you said C, you are correct. That one is divided into the equal parts. All right, let's look at this one. What's your fraction of each shape that is shaded? So I want the shaded fraction of this triangle. 1 part shaded. How many parts in all? Now, can you say that fraction? 1/3. Here's your circle. Did you do your thinking? So 1 part is shaded. How many parts in all? And say the fraction, 1/4. 1 part shaded, 2 parts in all. And do you remember how to say it? Don't say 1, 2. 1/2. 1/2. All right, same thing. Let's think about our fraction. How many parts are shaded? How many parts in all? And when we say this, we say 1/3. We have 1 part that's shaded, 4 parts in all. So what's our fraction? 1/4. 1 part shaded. How many parts in all? So our fraction is 1/3. All right, can you divide these shapes into equal parts? This time we want 4 equal parts. Can you think of a way to divide it? A lot of people like to go this way. Are there any other ways? There are. We'll see that in a few minutes. We want 3 equal parts this time. Shh. Did that work? Are those 3 equal parts? Nope, they're not 3 equal parts. So we need to get rid of that, right? Because that's not an equal way. Can you think of an equal way? Think about if it was a cake. If I was cutting the cake to the center, out to the side, out to that side, those would be 3 equal parts. Okay, 6 equal parts. There's several ways to do this. We could start there. We have 2 equal parts now. Then I could draw a line here. I could draw a line here. Can you think of another way? There are other ways. So if I was going to cut this cake a different way to make 6 equal parts, I could just draw little strips, right? And if I had drawn these nice and equal, which is hard to do when you're a person, but if I divided it into 6 equal parts, we did 1, 2, 3, 4, 5, 6. So that would be a way also. Okay, 6 equal parts this time. First, I'm going to divide it in half. Guess what? I'm going to connect the angles. So if I connect my angles and that was drawn perfectly, then I would have 6 equal parts, right? This time I want 2 equal parts. Is there more than one way to do it? I could divide it this way. How else could I do that? We could divide it this way. Oliver's having a moment. 4 equal parts. This one's always so tricky. Everyone always wants to say this way. But are those shapes equal? Nope. These two might be the same size. These two might be the same size, but they're not all the same size. So some are bigger, some are smaller. So we need to get rid of that. And there is another way. It's always so tricky. It's going to be 4 triangles. So if I go up here and I draw my triangle up top, then I can draw a triangle there and connect there, and you can get 4 equal parts that way. Let's go back to that square. I bet you were thinking about some other ways. So earlier we did this way, right? If I drew that equally. Did you think of another way? This is usually the next way that everyone always thinks of. And then we get stuck. So I'm going to give you a hint. First, we're going to start with vertical lines. If I draw 3 vertical lines, then I can have 4 equal parts that way. Now, if I draw horizontal lines, a lot of times if you draw in the middle first and then divide there, you can show, and no, these are terribly drawn, aren't they? But if I were to draw these correctly with equal parts in between, this would be a way to make 4 equal parts. So these are your ways to divide squares into 4 equal parts. Okay, let's practice with some word problems. So Jana wanted to share her cake with 2 friends. Would like to share her cake with her friend, sorry. So we're only dividing it between Jana and her friend. So what's 2 ways to divide the cake into halves, 2 equal parts? I know you thought about that one, and you probably thought about that one, right? Alex has a casserole. He wants to share it with his 2 friends. So it's Alex and his 2 friends makes 3 people in all. So I need to divide it into thirds, 3 equal parts. We could do that. Do you know the other way? Horizontal lines. Okay, Claire has a brownie. She wants to share with her 3 friends. So it's Claire plus 3 of her friends. So 4 equal parts. So you knew that one. Let's do one of the harder ones for this. We just looked at 4 ways to divide our square into equal parts, right? Okay, let's talk about this really quickly. So if it says shade in 2 halves of this shape. So if I divide it into 2 and shade this part and that part, then I've got 2 halves shaded. If I divide this into 4 equal parts and I shade all the parts, then I have 4 fourths shaded. If I divide this into 6 equal parts and I shade all the parts, then I have 6 shaded. What did you notice about all of those? For each one of those, the whole shape is shaded. So if your numerator is the same as your denominator, then you have the whole entire shape. So keep that in mind. All right, we are going to stop there for today. And I want you to review throughout the week, but this should get you through the packet and get you through the basics of what you need to know for fractions. If you have any questions, then let me know. But work through your Google Slides and work through you will have a test from this week. So have fun learning. If you need anything, let me know. Bye-bye.